All right, so today we're going to do dilations and rotations, and we have one essential question that you'll add to the pre-made notes that you were given. How can you tell the difference between a dilation notation and a rotation notation? Pause as you need to. So the first main idea we're going to talk about are dilations. And the definition of a dilation, it's a transformation that uses a scale factor to make the figure bigger or smaller than the original. So with dilations, the pre-image and image will be similar. So the shape doesn't change, but the size will. And they'll be similar to each other because notice it says it has a scale factor like we did in chapter 6 when we had similar figures. So this is the only transformation where it does actually change the size. When we did translations and reflections, size was preserved, and those, the pre-image and the image, were congruent to each other. All right, so let's do some examples. So first, we have another graphing one. So we're going to go ahead and graph these points. And then draw in the triangle. Okay. All right, so now we want to perform a dilation. So dilate the figure through the origin. So it's important that they say through the origin for these notations to work, and that's the ones that you're going to be responsible for on the EOC, with a scale factor of 1/2. So if I'm going to start with part C. For dilations, your notation is going to be where you take the scale factor and multiply it by both the x value and the y value. So when we're dilating through the origin, this is what we do. So I'm going to work backwards. So now I'm going to do part B. So if I plug in A prime here, I'm going to do 1/2 times 10 and then 1/2 times 2 to get my ordered pair for A prime, which would be 5, 1. You don't need to show this work that I'm showing you, but I just want to show you what I'm plugging into the notation, how the notation helps. And so then here I would do 1/2 times -4 for the x, and then 1/2 times 8 for the y. So that would be -2, 4. And then c prime would be 1, -2. All right, so we'll plot that and see what's going on. Okay. Now you'll notice that the dilation is not directly in the middle. And the reason why that is because we're going through the origin. So what this means, I changed to a different color, is if I were to measure the distance from the origin to B and the distance from the origin to B prime, the distance from the origin to B prime is going to be half of the distance from the origin to B. Same with A. If I drew a line here, the distance from A to A prime and A to A, the distance from A to the origin to A prime is going to be half of that other distance. And then the same with C. And you can kind of see that, like this distance here and this distance here look the same. Okay, so that's what we're actually doing when we do through the origin stuff. Okay. All right, so let's go to the next one. Maybe, there we go. Okay, so then there are some that you'll have to do that are not related to graphs. I mean, they have graphs, but you don't have to graph it. What's the image point of P, which is at 3, -5, after a dilation through the origin with a scale factor of 5? So go ahead and pause it and try that problem. Okay, so for example 2, what do we do with the scale factor at P prime? Well, you would have to multiply both of these. So times 5 times 5. So you should have gotten 15 and -25 as your point for P prime. Well, luckily you don't have to graph that one. Okay, example 3. On example 3, we want describe the dilation notation. So they're telling you it's a dilation that maps A to A prime. So what's going on from A to A prime? What are they doing to the X and the Y? Now they're multiplying by 2. So if you're describing it in words, we would say dilate. You don't have to put through the origin for me because I'll know that's what you mean. So dilate with a scale factor of 2. That's how you would say it in words. So you have to have that vocabulary term, dilate, and then we do need the scale factor part of 2. Or if you wanted to write the notation to describe it, I'm okay with that. So that would look like this. Oops. Where you're taking that scale factor and multiplying it by both the X and the Y. All right, and on example 4, I'm giving you the notation. So it's 2 times X and 2 times Y. So you would have to describe it in words. So dilate with a scale factor of 2. That's what you would need to write. And again, you don't have to put the through the origin part because I'll know that's all we're doing is dilating through the origin. Okay. All right, now let's move on to rotations. But first I want you to write in the left-hand margin, so this is a study question. So it goes in the skinny column that reflects the notes we've taken so far in this section. So it could be a level 1, level 2, or level 3 question, but you're not answering it yet, you're just writing it. All right, so on the next page, you can go ahead and do rotations as your main idea. And so a rotation is a transformation that rotates a figure a number of degrees about a point. So it may say about a point or around a point. A positive angle rotation means you're rotating counterclockwise. And I know that sounds like it should be the other way around, but it's not. And this is related to how we count quadrants. Remember, we start with the top right quadrant, and that's number 1, and then we go number 2 is to the left of it. So we go counterclockwise that way. It's related to that. Negative angle rotation means you go clockwise. Now this will be like we did before where I've done the computer has done it for us and we're going to see if we can figure out what's going on. And so we already put in A to A prime, B to B prime here, and C to C prime. You don't need to write anything, but I do want you to see if you can figure out the pattern. So go ahead and pause it and see if with your group you can figure out what this pattern is for this 90-degree rotation. Okay, so what are you noticing? What's going on here? Well, my hope is that you're noticing is that you're switching them. So -1, -2, you switch the 2 and the 1 spots. And then it's whatever the original Y value was is what's changing to its opposite. So notice that original X value, -1, stayed -1. But now we have this -2 has now changed the spot and it's been negated. Okay, so same here. So you switch around the numbers and then whatever the original Y value was becomes its opposite. Now here, when we switched it, the 0 can't be negative, and so it's safe. So then what's easy to show is from here, C to C prime. So here's what's going on. If I draw in the segment from the origin to C and the segment from the origin to C prime, I've gone now 90 degrees counterclockwise because it was positive 90 degrees, so we're going this way. This is the easiest one to see. So that has to be the same distance away, and then it has to be that degree measure. Now, if I were to show that with B, that's not too bad. So the distance from here to here and the distance from here to here have to be the same. And then this rotated 90 degrees counterclockwise. And same with A. Okay, so the computer, we just had the computer do it for us so we could see a pattern. Okay, so then in your notes, underneath rotation, here we're going to have 4 notations that you're going to have to be responsible for. So rotating positive 90 or rotating negative 270, these are equivalent because the negative just means we went clockwise 270. So if I come back here with this, not writing. So if I go from C, but I go clockwise over here, that's 270 degrees, but it's negative because we're going clockwise. That is equivalent to going positive, other way. That's equivalent to going positive 90 degrees. Okay, so that's why I have that negative there too. So these are equivalent to each other, and the notation won't change. It's always this. You switch it around, and whatever the original y value gets negated. The original x, which is now in the second position, stays the same. Okay, so if I gave you A is at, 3.6, then according to this, we switch the 6 and 3 around, and we change this one to its opposite. So that would be A prime, as an example. Okay. All right, now here you won't do anything, but you do need to pause it and see, looking here from A to A prime, B to B prime, and C to C prime, this is a 180 degree rotation. See if you can figure out what's going on with the notation, so pause. Okay, well, hopefully you saw that they're staying in the same spot, but you're just negating them both. Okay, so this was -1, -2, so now it's 1, 2. -1, 2, change the signs, 1, -2. Okay, and then if you see here, if again, the distance from here to A is the same as the distance from here to A prime, and we've gone 180 degrees. This would be positive 180, and if we went this way, this would be negative 180. Oops, I'm going the wrong way here, hold on. Got them switched around. So if I go this way, I'm going counterclockwise, that's the positive 180. And then if I'm going from here clockwise, that's negative 180. So here what you're writing is that it's positive 180 is equivalent to negative 180. So clockwise, counterclockwise 180, and negative 180 is clockwise 180 degrees. You just keep them in the same spots, but you negate both of them. Okay, now we're going to do positive 270. So if I'm looking here at C, positive 270 means I'm going counterclockwise 270 degrees. Here's what would happen. So pause this and see if your group can figure out what the notation would be here. Well, hopefully you said this. Positive 270, which is also equivalent to negative 90, you still switch them like we did the 90, but it's the original x value that's in the second position that becomes opposite. Here we switched them so that it was, if I originally just switched it, it would be -2, -1, but it's the y value, or the x value, which is your second number, becomes its opposite. Okay, so that is your notation. It's y negative x for a positive 270, which is equivalent to negative 200 or negative 90. And then the last rotation is the easiest one. You don't really have to think about it because A and A prime, if I'm going 360 degrees, means I'm going to be back where I started from. So that's why all of these are the same for 360. So the notation for 360 is just the original XY because you've gone all the way around and ended up back on the same point for a 360-degree rotation. Okay. All right, so for this, let's go ahead and graph. So we'll do one graphing one here. 0, 3. So a little itty bitty triangle. And we're going to rotate 90. So I'm going to start from the bottom from part C up. So remember, this doesn't change. So the notation for this, you're switching them, and the original Y value that's now your first number becomes its opposite. Okay, so if I go to do part B, A prime, so if I plug that in, A was at 0, 3. So we switch them, and then this is negated. So that should be -3, 0. Okay, then I'm putting in -2, 2. So we switch them. So that'd be 2, -2 if I just switch, but then the original here becomes its opposite. So then B prime is at -2, 2, -2, -2. And then C prime, if I put 1, 2 here, you switch them to 1, and then this one becomes its opposite. So it'd be -2, 1. Then we'll plot the points. So -3, 0, -2, 2, -2, 1. So this is our rotated 90 degrees picture. Same size and shape, so rotations keeps the size and shape, so the pre-image is congruent to the image. All right. We have to graph. What's the image of point A after a rotation of 270 degrees about the origin? Go ahead and pause and then try this with your group. Okay, so then this one, remember, is the notation says we switch, but it's y negative x. So then if I plug that in, its time should be at -5, -3. So that's what you should have gotten on that. Okay, example 6, or I'm sorry, example 7. What's the image of point B after rotation of 180 degrees about the origin? Pause and do that. So remember, this one is where it's changed. They stay put, but you negate both of them. So then B prime for this one would be at 2, -7. All right, so this one we're going to talk about rotational symmetry briefly. But basically, if I were to take each of these, so if I had a pentagon, a regular pentagon, so it's all the sides are congruent, and I have the center point right here. Okay, and so if I rotated this around this point, how many degrees would it take so that this point is now rotated onto this point and all the other points have been rotated a certain amount of degrees, whether you go that way or you could go counterclockwise, either one. So basically, to figure out how many degrees this angle is, if I drew all of these in, we would do 360 divided by 5, which would be, what is that? So 72, which is not a rotational symmetry of 120, because I could do 72 and any multiple of 72 degrees rotated there. So it's not a regular pentagon. Okay, if I had a square, and again, this only works with the regular polygons, and I did that, well, I would want to know if I were doing from here to here, rotating about this piece, if I'm going from this point to this point, how many degrees would that take to do that? Well, that's going to be 90, which is not what we want. A rectangle, since it is not congruent on all sides, a rectangle has a 180-degree rotation about the center point. Because if I just did 90, then it would be this figure straight up and down like this, which is not what we want. And so this one would be 180 degrees, and so not a rectangle. And so the one that's left is an equilateral triangle. So again, because if I did here and I wanted this point to rotate to that point and all the others rotate on top of the others, you have to figure out how many degrees this angle is right here, which is 360 divided by 3, which is 120. So I could rotate this either clockwise or counterclockwise 120 degrees where the vertices would fall on top of each other. So D is the correct answer on that. That we'll talk more about, but I did want to introduce that. And you've probably heard of rotational symmetry before. I know you've heard of line symmetry, which we didn't formally cover, but that's, where you can draw a line and it cuts the figure in half. Okay, so for the rest of the time, go ahead and work on that worksheet. And again, it's not optional. I will collect it when I return. Okay.